Hello and welcome back to Crystallography for everyone. In this video, we are going to introduce the concept of a basis. This is another definition that I think is very important. A basis used in conjunction with a lattice is how we make crystals. So I'll give us this definition. A basis is an object that we assign to a lattice A basis is an object assigned to a lattice point. By definition of our lattice, if we assign an object to one point, we assign it to all points. Going back to the periodicity of the lattice, how every point is indistinguishable and how every point has the same surroundings. Does that ring a bell? I think after the past few videos, you are probably reciting those with me. I think that the best way to demonstrate what a basis really is to go back to 1D and then work back to 3D, the same way we did with the lattice. So we're going back to line world. We're going to go plus and minus x direction. I can draw some more lattice points. Space them out decently. And now I'm going to define a basis. I'm going to decorate the lattice points. Each lattice point is going to get an object assigned to it. So in this case, I'll just have this little circle, and it's going to go on each lattice point. I'll actually draw it more like this. Right now, our basis is just telling us that this circle goes on each lattice point. The object in our basis is not constrained by the same rules that lattice points are. This is not a mathematical construct. What I mean by that is this can be a real object. This point can have, or this object can have mass, can have volume. It can be made up of other smaller objects, protons and electrons and neutrons. I'm not limited to the number of objects I can use in my basis. So I can draw some other points here, some other objects. Now my basis looks like this. This construct here is applied to each lattice point. So you can see that. And this goes off to infinity in each direction. Now we're really getting somewhere. We aren't just purely in math world. We have some real objects I think at this point, it's a good idea to move to 2 dimensions. So I will hide this and move to a new layer, and we can start drawing out our 2D lattice. Instead of drawing the individual points this time, I'm going to just draw these intersecting lines. And I realize I can use technology to do this much straighter. Much straighter. Each intersection here is a lattice point. And I can apply a basis. So we have a roughly rectangular lattice here. I'll draw in our lattice vectors, A and B, and where we have a 90-degree angle there. So we could call this point 0, 0, in which case this point would be 1, 0, and then 2, 0, and we have 2, 1, sorry, that's not 2, 1, that is 0, 1, and then this one would be 1, 1. I can create a basis for 2 dimensions. I can say that at 0, 0, we have this blue atom. It could be any atom. Call it the A atom. Realize this might not be blue. Probably a good time to mention that I'm colorblind. We could also put another atom in at 1/2 and 1/2. Call this atom atom B. So I'll apply that to a few of these points. Here's A. So at every lattice point, we're going to have A. And then at the center here, 1/2, 1/2, we're going to have B. And this is where the critical concept of a basis comes in. Point 0, 0 and point 1, 0 are indistinguishable. And that's what we know from our definition of a lattice. So we could interchange these. Right now we have our B atom attached to the 0, 0 here. We could just as easily call this atom 0, 0. And we could just as easily call this 1/2, 1/2. We are assigning our basis to every single lattice point. It's just convention to call the lattice point 0, 0, and then whatever other points we can give other names inside of, in between the points. What we wouldn't say is our basis is 0, 0 for the A atom and 1, 1 for the B atom, because 1, 1 would be the same as 0, 0. I hope that makes sense. I'll draw a few more points here so you can start to see how the basis works. So I'm assigning all of the 1/2 B atoms. Then I'll draw in quickly the A atoms. In reality, the A and B atoms could be the same. I think that right now it is more clear to use two different atoms, but they don't have to be. Our basis could be anything. Our basis could be some molecule at 0, 0 and an atom at 1/2, 1/2. We could change this to 1/4, 1/4 and put the atom right there. We're going to do quite a few examples of being given a lattice and a basis and putting them together and drawing out the structure so that you can immediately visualize what someone means when they say silicon has a face-centered cubic lattice with a 2-atom basis. That's going to be one of the next examples that we go through. But at this point, I think that it's worth skipping showing 3D lattices with bases and defining a unit cell. So in the next video, we are going to look at the concept of a unit cell in 2 dimensions. I hope to see you there.